Hey everyone, it's Naz from Astronomy. In July 2022, the way we see the universe changed after JWST dropped the mind-blowing images of the universe. The one that I fell in love with the most is NGC 3324, nicknamed the Cosmic Cliffs. It's an open cluster in the Great Carina Nebula. It's only visible from the southern hemisphere, so I was glad when they made the data available immediately so that amateur astronomers like myself can take a look at the data and process it ourselves. I downloaded the data and gave processing it a try through Astro processor and Photoshop. My first time around I accidentally left out a filter, but I want to redo it with the missing filter. So let's see how I downloaded the data and let's start using it in Astro processor. To download JWST data, you want to head over to mast.stsci.edu. You don't need the rest of the URL. The best way I found is to just know what you're looking for. So if you enter the object name, in my case it's NGC 3324, which is the open cluster in the Carina Nebula. It's where the Cosmic Cliffs is. The whole picture is not actually Carina Nebula, it's just part of it. It loads pretty fast, but sometimes you'll notice that it can get very slow, especially if you're looking for an object that has been photographed by many other missions. But it took me just a few seconds. On the left hand side under mission, if you click on search see more, you'll see JWST here, and it'll filter even more. And there are two instruments that JWST used to image this. So we have the mid-infrared, the MIRI, and the NIRCam, which is the near-infrared, and that's the data I am going to download. The last time I missed downloading one of these filters because I think it's like mislabeled. So a couple way to download this is you can click on the little save icon here, the floppy disk, and download each of these one by one, or you can add them to your download basket. Just select what you need, click here, add to download basket, and it'll add to a download basket that you can download as a whole zip. The one thing to know about this is that it can be very slow because it's trying to generate the download files for you. So that took about a minute or so, and it gave you everything you want here. You can expand these options to look at what you'll be downloading, which includes some maps, some CSVs, a FITS file, and that's what we're going to be looking for. So you can actually open these, select the objects you want and just download that, or you can click on the whole thing and click on download. And depending on your connection speed and how slow MAST is doing, it can take a while because it's about, and as it says, about almost 14 gigs of data. So it'll compress it down to about 9 gigs and it'll download a zip file for you. So I won't make you go through that because I've already downloaded the JWST data here. So if you download the individual files, you'll get the zip files for each of these filters here. It just has a timestamp, which isn't the best, but you can see it's about 9 gigs of data. Or if you download it in a basket, it'll give you one big zip file, about 9 gigs of data. You'd have to extract, and you can see all the files within JWST here. So I downloaded them both ways just to see if there was a difference. There is not. I extracted all of these and I named them the different filters. The way I find out which filter it was using is by going into the directories here inside the JWST, and this directory name here, it has what it's using, and F is for filter and 090W is wide. That's the filter it's using. So that's the bandpass. So if you go in there, you'll see the various files here, and the one we're looking for is this almost 3.5 gig FITS file here that will open in Astro processor. You don't need the other ones. I think if you open this in PixInsight, you get a lot more data, which I don't really care about right now. And there are all of these here. So the one thing I initially missed, the 470N, it's because the folder name had two filters here, F444 and F470. So I missed that initially here, so I didn't see that, so I thought there were two F444Ws, so that's my fault, so I missed it, but I still got a pretty nice image and I get to make a video out of it. And before we open Astro processor, if you search for NIRCam filters, you'll land on this STSCI documentation page, and they give you some guidance on what the different filter colors they assigned. These are not true colors, all false colors, all taken in infrared or near infrared. But you can see that F444W that we saw on the list here is assigned red, We have F090, it's purple, and so on and so forth. So you can use this as a guide, but you don't have to. It's false color, so you can assign whatever colors you want. I'm going to try and get as close to the official JWST image as I can, and we'll see what we come out with. So I'm going to start AstroPixel Processor. So I created a directory called NGC3324 here. So I'll click on Open, and then I can move APP here. The first thing we want to do is we want to add all of the FITS files that we have as lights. So I'm going to go add them. So here's my list of files. So I'll add 090W first. Go here, clear. And then it will be not the segmentation file, but the I2D file. So I'll click on this, open as light. Just press OK, OK. And I'm going to do the same thing for the rest of them. So I'll skip through the video while I do that. Okay, so I have all 6 filters loaded here. These are big files, so APP can sometimes take a little while to load each of them. And the one thing I will notice is that you'll see that I'm using 16 gigs of RAM for this. At a certain point, it uses a ton of memory. So if you have a computer with like 4 gigs of RAM, you might have trouble processing this. So I went into the configuration, I changed it to 16 gigs. I have a total of 32 gigs on my computer. Okay, so that took a little while to load, and that's because the data is just so large. You can see this upside down from what we saw in the official JWST image. But here is filter 090. You can see it does a lot, so let's quickly go through each of them. This is filter 335. You can see just how different this one looks. It looks so much brighter than nebulosity here. This is filter 444W. And finally we have filter 470N. You just saw the vast differences between the 6 filters. A lot of time can be spent just waiting for these images to load because they're so large, but that's alright. If you're wondering why I added them as lights, it's because they're not perfectly aligned, so we need to register them. So after I load, I'm going straight to tab 4. I'm just going to click on register, start registration, and then we'll save the registered frames and work with those only. So we won't need the FITS files anymore. So the registration completed successfully, so I'll do save registered frames. Okay, so saving the registered files took a while, and it created 6 new reg.fits files inside the directory I created within my APP directory. So now we can pull this into our tools and go to combine RGB and pull them in. So we'll just call this NC3324. Once we're in the RGB tool, we can add channels. And we're already by default in the folder that we created earlier, so we can just select all of these, and it'll ask us to assign them to various channels. So it's going to look at 090 first. It's if you look at the color map here, where did it go? You'll see that 090 is like to the purple side. So I'm just going to leave it as custom, but I will change the formula to HOO, H-O-O, for now. We can play around with them later. Next will come up is 187. So 187, they say, is here. So it's also blue. It could be in the H beta range, but I'm just going to leave it as. Actually, I'll assign it to hydrogen beta. Again, these are all false color. It doesn't really matter what you assign them to. You can make some really cool artistic choices with all of this. So now we're looking at 200W. So 200W is here. So I'll assign this to oxygen 3, although it's very wide for O3. Next up, it's doing is 335. 335 is in the green range. I'll leave that as just custom. I won't put that on O3 or anything either. And then the next one is going to be 444W. You can see it already that it's in the red range. So I'll assign that to hydrogen alpha. And the last one should be 470N. Yeah, so you can see that's in the very red. The sulfur 2 wavelength is even redder than hydrogen alpha, so I'll just assign that to, I could also do H alpha for this, but I'll just do sulfur 2 for now. And then they will get added to Astro Pixel Processor here, so we have them here. So the idea I had was to just try and mimic what we see in the charts here and what we see in the JWST image. So since we selected HOO, it automatically assigned values to the hydrogen alpha and the oxygen 3 channels. So if we do recalculate, it'll calculate that and output something. But because like sulfur 2, our 187 and 090 and 335, they don't have anything associated with the HOO formula. They're all at 0. But you can see that this is what it looks like in HOO. I'll hide that in HOO, and it looks pretty good, right? It's only using 2 filters, which is amazing. This is just the clarity of the JWST data. It's very, very clean, very crispy, as I like to say. So now we want to start trying to mimic everything else with this. So let's play around with some of this. So 090 is purple. If you look back here, it's purple. The way to get purple is to do equal parts green and equal parts blue. You can get like an RGB simulator somewhere. I work a lot with RGB lights. So I'm just going to set this to maybe 50, and then let's try that. So it's adding some. So I'm going to change the intensity down to 0 for now. I'll come back to that. We have hydrogen beta here, which is 187. So I'm just going to increase the blue a little bit here, and then do recalculate just to see what it looks like. Here it goes, looking pretty good. So I opened the official JWST data just to see what it looks like. It's very orange, lots of blue here, some purple here, some bluish purple here, and what we have is what looks like this. It's not close, but you know, it's pretty good, right? I mean, I would actually be comfortable sharing something like this because it does look very nice. The next one we're gonna look at, next filter we're gonna look at is 335. It is hydrogen. It is in the red greenish spectrum, right? So increase red and green, so you get like lime, like orangey color. So let's try 50. I like setting things to 50, and then let's recalculate. Okay, it looks a little bit yellow, but it's fine. We can play around with the settings. Let's see which one we didn't touch. So the hydrogen alpha is red. We can change the intensity to 2. We can do the intensity to 2 here as well. 187. Let's see, recalculate. This part is a lot of just playing around with the buttons and seeing what happens. Oh, and I think I changed the sulfur, not the 335. So I'll do that. 50. So this is sulfur, so it's going to be more red, so I'll just decrease that. Doesn't look like a lot has changed, so I'm just going to up the red on the sulfur. Let's do that. Maybe to get a little bit more orange, we'll increase the red on the 335. We can also click this button here, the saturation button. It'll add some more saturation to this so we can see what the final colors will look like when we export this into a TIFF. It's looking a little bit more colorful, so let's see. The H alpha is here. Decrease the green on this. Okay, so I didn't bore you with all of my adjustments for these little settings for the past hour or so. I thought I would skip to the end and show you my final result in this tool here. It doesn't look as orange as the JWST image released by NASA and ESA, but I think if I follow the NIRCam filters, the guidance they gave with the colors, I think it matches a little bit more with what I have. It's a little bit less orange, less saturated. I kind of think it looks a little bit more more in line with what they have here. So I'll quickly go over what I did. So filter 090, you know, it's purple here. So purple, you get purple by combining green and blue in an RGB color combination. So I put 70 on each, so it's about 35, 29%. So I can adjust this a little bit more. So next filter is 187. So 187 is blue here. So it's like a kind of like a aqua color. What's that color? Is that teal? No. Cyan? Yeah, cyan. That's the color. So 187. So that's why I put hydrogen beta. Hydrogen beta is around here. Like if this wavelength was the normal wavelength, so hydrogen beta would be there. So it's mostly blue. You know, I put it at blue. It's only 29% of the total composition of this. So I think that's fine. Next one is 200. So it's, you know, I did mark it as oxygen 3. So it's gonna be like green and blue. So this is 200. So this is also kind of like a cyan color, but much wider. So I put that as 100% blue. You know, 100 strength at blue and 3840 at green. So we get a more color that looks like this. And you'll see that the color of the background kind of matches that here. It's like a teal cyan color. The next one is 335. So we know it's very green here. So it's green yellow. It goes into green and yellow. And to get green and yellow on this, you have to combine red and green. So the more red you go on the green, the more yellow it becomes. So that's, I mean, I'm making up these values, but this is how I achieved that here. So you can play around with this and see what you get. Next is hydrogen alpha. So 444W is red. So I boosted it to 100% red here. So just gave it all that. And similar for sulfur. You know, it's all red here, but it does fall within 444W. So I put it at 100% red and added a little bit of green so that it turns a little orangey. So that's how you get orange. So this is what I came up with. Lots of cyan spikes here. You can see some orange spikes here. So I think it looks pretty good. So I'll click on save. So once that's saved, you click cancel, and that showed up here. So all the other files, they disappeared because I had to restart APP. So we'll double click this, we'll open it in our viewer. So we have this open here. So what we can do is we can do a rotate and crop. So let's do this. We'll do a flip on the y-axis. So there we go. It looks a lot better, right? So we'll click rotate and resize. Alright, so that's saved. So I'm double clicking this to open, and then we'll do a crop of this. We'll open in the cropping tool, so we can just select from there to here. So we can get rid of the breaks on the outside. Crop. And there we go. So we have it cropped. And let's open it one more time. We'll send it to our HSL selective color. We don't need to do any of these because the data here has already been calibrated, so we don't need to do anything else with them. So we'll just do HSL selective color. Great, that opened here, and then we can use this tool to adjust some of the colors here. So there's a lot of cyan here, so if you want to turn them to bluish, what you can do is you can click cyan. We can go from, let's say background 50%, and do show color selection. It'll show you exactly what it's selecting. So all the white parts is what, if I update as cyan here, will update. So we can look here, so we can say cyan, so you can see cyan is here. So if you move it towards the red, it'll become less cyan. So if I move it 20 and move the blue 20, so it's a little bit bluer, and click on calculate current adjustments, there you go. A lot of the cyan has gone down. It looks more whitish, but it doesn't look as cyan as it used to. So we can keep playing with these as well, and then I can just play around with the blue. Now you can see it's a lot more blue, but it doesn't look great here, so I'm going to switch it back to what it was at 20. So what I settled on the cyan is minus 25 red, minus 25 blue, and 30% saturation. So we can move on to the red and yellow. This is probably going to be this piece, so we can do, let's do yellow, and then do show color selection. So we'll see exactly what part of this is being affected by the yellow spectrum. And it's suspected it's all of this. So I think if I do red as well, it'll find that as well. So the way to turn it more orangey would be to go a little bit more towards the red here. And then go away from the blue is to go away from the yellow is to go towards the blue as well. So I'm gonna set it to -25 and then see what that looks like. See, it looks a little bit more orangey than before. So I'm gonna move it towards a little bit more towards the red. So we'll do 40, more towards the blue, and then we'll see what that looks like. So this is what I see after I do some of the yellow. I don't know if I like it too much, but I'll keep it for now. We can adjust this in Photoshop. And then next thing I'll do is go to the red. I already know what it will select, but let's do show color selection anyway. So also as suspected, the yellow-orange area is also red. So I want to turn up the red a little bit so that we get less yellow. And I'll pick up the saturation. So let's see if I do calculate current adjustments. The one thing you can do is you can click on show original image here, and it'll show you what your original settings were, and then you can quickly do calculate current adjustments. It'll keep all of your adjustments, so you can do a little comparison. So if you end up making a mistake and it looks worse somehow than it did before, you can always switch back or cancel and then try again. So while that loads, I'll show you that the red, it looks like this. I just went a little bit to the red, left everything else blank. Yellow, went a little bit to the red, and blue, and pumped up the saturation. For green, I didn't do anything. For cyan, I turned down the cyan. Blue, I didn't touch anything there, so I can apply a little bit more blue to it, see if I can get some darker blue there. Magenta, I didn't touch anything. It's just, I think it's just going to affect some of the outlines here. And then you have gray, which is black and white and all. You can do that if you want to. So I think I'll go to blue. I will adjust this a little bit and then do calculate current adjustments. This is one final look before I go out of this tool. So this is what it looks like. The stars don't have the cyan fringing, not as much. This one kind of does too if you zoom in. But it looks pretty nice, I think. It looks close-ish to what NASA took out. They do have darker blue here, some golden stars, more gold around here, and mine is a little bit more yellowish, but we can try and fix that. But again, it really doesn't matter what the image looks like. It's all false color anyway, and how it looks is just based on what you think looks right. And this is what NASA thought looked right, and this is what I think looks okay with what I was able to do. So I'll save. When you get the prompt, you can click save or change the name. Okay, once it has saved, what you need to do is just click cancel. It doesn't close out right away, and then you'll see your file here. So it's the SC fits. It's the selective color. That's what the SC stands for. Okay, so it got loaded here. The one change I made on the right side panel is the contrast. I put it to about 9% so that we can see some more contrast between this, because it does look a little bit smooth compared to the contours and other parts that you can see here. But I'll try and get that back in Photoshop. And I'm not touching anything else. You can play with the saturation if you want, but I think it looks pretty well saturated already. So I'll click save, and it'll prompt me to save it as a TIFF file so that I can open it in Photoshop. Yeah, so this is the prompt. So I'm just going to set it to, again, just C3324 who, save it as 16 bits. Okay, so that's saved, and now it's a TIFF file, and I can now open it in Photoshop. Okay, so I have the TIFF file open in Photoshop. So this is what AstroPixel Processor exported, and I'm going to try to match it a little bit to this, but that's not my primary goal. My primary goal is to just make this look a little better than I understand. It does look very bright, so normally in my images I would boost up the luminance, but I think I have to bring it down in this shot. So I have the background layer here, so the first thing I'm going to do is I'm going to duplicate it, so I did Control J, and then I'll just hide that, so if anything happens I can delete all these other layers and then go back to background and start all over again, which I've done a few times with pretty much all of my images ever. So I'm going to open up the camera raw filter here. Okay, so once camera raw opens, only place I'm going to do one of the places I'm going to look at is color mixer. So we have hue, saturation, and luminance that we can adjust, a little bit similar to what we did in Astro Pixel Processor. So I'm going to turn down the luminance of the orange so that it gets a little bit more manageable. So I can turn down the reds too, so that you can see more of the contour and the shapes and the grooves. If I turn up the yellow, you can see that the surface here kind of gives it a little bit of extra layer of detail here. So I'm going to do that here. So I'll pull it up. You can click on this little eye to toggle the visibility, so you can see what it looked like before and after. Before and after. If I look at this, you can see that it is a little bit darker. It is more golden, like dark gold color. Again, that's not my goal, since I did already not do a lot of that from Astro Pixel Processor. Let's see what the blues look like. So if I turn down the luminance on the blue, you can see that this starts to get a little darker. So I'm going to do that just a little bit. One thing I did notice is, even though I did add all 6 filters, sections like here are translucent or transparent. If I turn down the green, you can see that the greens here change. But anyways, I just wanted to turn down the luminance of the orange and the reds so that it gets a little bit darker. If I look here, you can see that how bright it is in the background here. So I'm going to now go to the hue and change. Let's play with the orange. I think you can see that it gets very magenta-y, and if I go here, it goes very lime yellow, kind of. So if I go here, if I look here, you can see it looks similar. You know, it's not exactly the same, but pretty close, right? So this is more golden. This is more orange. So maybe I have to go this way, and I'll do this and this. I think that's actually much closer. So this. Yeah, it looks nice. The JWST image does have a lot more detail here. Mine is just a little washed out, but it does look like there's like a whole bunch of data that I don't have for some reason. But anyways, let's play with the other settings. So I go to the extremes to see what I am affecting. A little bit redder here. Go to the yellow. You have the greens. It seems to affect stuff on this side of the nebula. I think I'll leave that. So we have the aquas. I'll leave that as well. And then the blues. That's the sky portion of this image. I think that looks pretty good. Mess with the purple. Okay. So again, before, after. Okay, the next thing I'm going to play with is the saturation. So again, I can see exactly what I'm affecting. Not a lot. Orange. Of course, I'm going to need some orange. If I do pick up the blue saturation, the sky gets bluer. If I bring it down, it gets gray. So I think I'll do maybe 14. And then we have like the little lime here, the green here. Let's see if I can bring that down. Yeah, it's the aquas. We'll go back to hue just to mess with the aqua a little bit. See if I can affect the star. And yeah, it is the aqua. I'll bring it here. Okay, I think that looks pretty good. And this is the luminance that we already edited. So this is mine. This is JWST. And I'll also bring up my first version. So this is my first version. First version, second version, JWST. It's pretty good. Yeah, JWST is pretty yellow up here. I am more yellow here, but we can also look here at the basic column and see if we can add anything. So if you mess with the contrast, you can see more of the detail. So I can bump that up to maybe 20, 21. Yeah. Let's do 25. So 26, sure, why not? That looks pretty good. If we mess with the shadows, yeah, I can bring up some more detail like in the centers. So I can do a little bit of shadow there. And then we can play with the dehaze. I think if you do dehaze, it does make some of it darker. Dehaze is actually really good if you're taking images from your backyard. It does help with some of the light pollution. I'm just going to do maybe a 7. Yeah, just so I can see some more detail here. Play with the clarity too. Might not touch it. Maybe 6. Let's do that 10 too. Just to make it a little sharper texture. And then we can play with the vibrance and saturation. You know, vibrance and saturation. If you want to do like a faux monochrome, or I guess a full monochrome, here you can see that it looks pretty solid and not translucent at all in mono. Yeah, to tame it down, I can do like a -5. Looks okay-ish. Okay, so I'll get out of this. There you go. So that looks good. And we can go back and look at our background layer anytime. Cool. And I'll add a little curves layer, so you can do it if you have this adjustments here, or you can do layer, new adjustment layer, curves. There we go. Do a slight curve. This is the curves. If I do this, I may have gone overboard with the yellow here, but again, it's all art. You should do it whichever way you think looks good. Merge all of these layers and then get the one so I can hide these. One thing you'll notice that some of the brighter stars have like this black center. How I usually fix that is by using the spot healing brush. Just going over it, and then it just fills in. And I'm going to do that for all of these and come back. Okay, I'm back, and luckily it's only the brightest stars had that black center. Anyways, I think I'll call this my final product of my version 2 of the Cosmic Cliffs of NGC 3324. So after I showed you the final result in Photoshop, I stared at the image for a while, and I made some slight changes in the hue, saturation, and luminance options in the camera raw filter in Photoshop, just to get it a little bit closer to JWST. Again, I've mentioned this many times that it's all false color, so it doesn't really matter. And I hope that the tools I showed you in Astro Pixel Processor and Photoshop can help you find your own way into processing images from JWST. I hope this video was a little helpful in showing you Astro Pixel Processor and Photoshop, as well as how to download JWST data and just process it yourself. I would encourage everyone to try it. Getting the data is free. Astro Pixel Processor is not free, but there is a free trial. And everything I've shown you in Photoshop, I think can be done in GIMP as well, which is free software. Thanks for watching. I hope you enjoyed the final results of the Cosmic Cliffs. Clear skies.